Good morning and welcome to today's class. Today's class is a continuation of our previous classes on trigonometry. At the last class, we have looked at the basic trigonometric ratios, which includes the sine, the cosine, and the tangent with respect to a right angle triangle. And at that class, we were able to solve so many examples on trigonometric ratios, where I gave you the basic numeric ratios as sine theta, cos theta, and tangent theta, and I say that sine theta is said to be the relationship between the opposite side and the hypotenuse side, as well as the included angle. We also looked at the sine theta, which we said is a ratio of the adjacent side to the hypotenuse side of a right angle triangle, as well as the tangent of an angle is said to be the ratio of the opposite side to the adjacent side of a right angle triangle. We also went ahead to solve so many examples using the trig tables to get the values of sine theta, cos theta, and tan theta, where I did explain to you how to make use of the trig tables. I did explain to you how you can find a given angle when the trig ratio of that angle is given. At the last class, we looked at word problems leading to trigonometric ratios, where we solved a lot of exercises. In today's class, we shall be looking at solving problems on right-angled triangle. There is a relationship between the sides and the angles of any triangle. And in a right-angle triangle, the relationship is the trigonometric ratios of sine, cosine, and tangent. Accordingly, we said sine theta is given as the ratio of the opposite side to the hypotenuse side of a right angle triangle, while the cosine is said to be the ratio of the adjacent side to the hypotenuse side of a right angle triangle, and the tangent of an angle is said to be the ratio between the opposite side or over the adjacent side of a right angle triangle. And in those days, we had a simple trick in memorizing all of this. We abbreviated it as SOHCAHTOA. This is SOHCAHTOA, where we said so is said to be that the sine of a given angle in a right angle triangle is said to be the ratio of the opposite side over the hypotenuse side. That means that O stands for opposite and H denotes hypotenuse, while this is said to be the cosine of an angle, that the cosine of an angle is said to be the ratio between the adjacent side of a right angle triangle to the hypotenuse side, while the tangent is said to be the ratio of the opposite side to the hypotenuse side. So with this, you can memorize what we meant by sine theta, cos theta, and tangent theta. Also, the square on the hypotenuse side is equal to the sum of the squares on the other two sides. That is to say, if you have a right angle triangle ABC, where angle B is said to be of 90 degrees, that the square on the hypotenuse side is said to be the sum of the squares of the other two sides, given as B squared is equal to A squared plus C squared. So with this and the trig ratio which we did earlier on, you can be able to solve any problem that has to do with a right angle triangle. So I shall be proving to you today the Pythagoras theorem, which states that the square on the hypotenuse side is equal to the sum of the squares of the other two sides. So that is our focus in today's class. Pythagoras theorem, theorem 1, says that the square on the hypotenuse side of a right angle triangle is equal to the sum of the squares of the other two sides. So we shall consider triangle XYZ in proving this. In this question, we have been given that triangle XYZ is with angle XYZ being 90 degrees, while side XY, which is this, is said to be Z, and side XZ is given to be y, while yz is said to be x. Now the question says we should prove that y squared is equal to x squared plus z squared. So how are we going to prove this? In order for me to prove that y squared is equal to x squared plus z squared, I shall draw a perpendicular. A perpendicular is a straight line drawn from y to line xz. So if I should draw this perpendicular, it therefore means that this is angle 90 degrees. Let me call this side R and this side S. If this meets xz at the point M, then it therefore means that line xm is said to be R and line mz is said to be S. So we have to prove. I will say if we consider triangle YXM, I will call this angle theta, and let me call this angle alpha. That in considering triangle YXM, which is this triangle, that cos theta is said to be the ratio of the adjacent side to the hypotenuse side. Now with respect to triangle XYM and angle theta, this is said to be the opposite side, while this is the hypotenuse being the longest side, and this is the adjacent side. So the cos theta is said to be the ratio of the adjacent side to the hypotenuse, and the adjacent side is said to be R divided by Z. Let me call this equation 1. And also, if you consider triangle YZM, you will also agree with me that cos alpha is equal to, now with respect to alpha, this is also the opposite side, this is the adjacent side, while this is said to be the hypotenuse side. The cos is said to be the ratio of S divided by X. Call this also equation 2. Now, if you consider triangle XYZ, when you consider triangle XYZ, we'll also look for the cos theta of this angle. Now, with respect to triangle XYZ, this is said to be a 90 degrees. Then, with respect to angle theta, here is said to be the opposite side, Y is said to be the hypotenuse, and XZ is said to be the adjacent side. So with respect to triangle XYZ, cos theta is said to be the ratio of Z over Y. Let me call this equation 3. While cos alpha is said to be the ratio of, since this is alpha, this becomes the opposite and this becomes the adjacent with respect to alpha. So cos alpha now is said to be the ratio of the adjacent, which is X, divided by Y. I'll call this equation 4. Now, since equation 1 and equation 3 are said to be equal to cos theta, I'm going to equate equation 1 and 3. Equating equation 1 and 3, this is said to be equal to R over Z is equal to Z divided by Y. I just equated equation 1 and 3. And when you cross multiply or simplify, you are going to have it that Z squared is equal to RY. Let me call this equation A. While when you equate equation 2 with equation 4 being cos alpha, this gives us X divided by Y is equal to S over X. Now, when you cross multiply, this gives us X squared to be equal to SY. call this equation B. Now, adding equation A and B together gives us, I'll add those on the left hand side with those on the right hand side. That is to say that this becomes x squared plus z squared is equal to ry plus sy. When you factorize out y from the right hand side, you will have x squared plus z squared being equal to y into bracket r plus s. And if you go back to a right angle triangle, you will discover that r plus x is equal to y. Now let's look at it. R plus s is said to be equal to y because it was when we drew this perpendicular bisector that divides y into r and x. So therefore, r plus s is said to be y. That is to say that x squared plus z squared is equal to y times y. And y times y gives us y squared. That is to say that x squared plus z squared is equal to y squared. And that is what we are asked to prove. That we should prove that the square of the hypotenuse side is equal to the sum of the squares of the other two sides. And that is what Pythagoras' theorem is all about. So therefore we said, if in a triangle, the square of one side is equal to the sum of the squares of the other two sides, such a triangle is said to be a right angle triangle. Now, with these two theorems, that y squared is equal to x squared plus z squared, and the trigonometric ratios which I gave us as cos theta, which is equal to be the ratio of the adjacent side to the hypotenuse side, sine theta, which is the ratio of the opposite side to the hypotenuse side, and tan theta, which is said to be the ratio of the opposite side to the adjacent side. With this formula, you can be able to solve most of the problems that had to do with a right angle triangle. When you're asked to find any given sides or any given angles, you can use any of these formula to solve problems in right angle triangle. So let's take some examples.